So good morning everybody. Today me, Bella Erica S. Esteban will be discussing about real numbers. So what are real numbers? A real number is a number that can be found on the number line. A real number can be either rational or irrational.
I'm going to be introducing the real number
system. So real numbers are simply the combination of rational and irrational numbers in the number system. As said, a number can be either irrational or rational. So I'm going to be discussing about the rational number. So a rational number is a number that can be expressed as a fraction where both the numerator and the denominator in the fraction are integers. The denominator in a rational number cannot be 0, and a rational number can be a repeating decimal. So here are the types of rational numbers. We have the integers, whole numbers, and natural numbers. So integers consist of all of the positive and negative numbers. Whole numbers are all the positive numbers starting with 0. Natural numbers, which are also known as counting numbers, which means that they start with number 1. And also under rational numbers, we also have the repeating and terminating decimals. We also have the perfect squares and perfect cubes. So what are integers? Integers consist of all the positive and negative numbers. A positive number is always larger than a negative number on a number line. The negatives closest to 0 are greater, and the positives that are further from 0 are greater. Adding integers. There are some rules that we need to keep note of when adding integers. 1. When the numbers have the same sign, add them normally and then copy the sign. We have negative 4 plus negative 5, which is equal to negative 9, 6 plus 9, which is equal to 15. When the signs are different, subtract and keep the sign of the higher absolute value. Then you'll be exact. We have negative 12 plus 7. So first we have to subtract 12 and 7, which is equal to 5. And since the larger absolute value is 12 and 12 is negative, the final answer is negative 5. Subtracting integers. For subtracting integers, you have the rule of keep, change, change. Keep the first sign, change the operation to addition, and change the second sign. For an example, we have negative 9 minus negative 3. So negative 9 plus 3 is equals to negative 6. Here are some examples to help you multiply and divide integers. Negative 6 multiplied by negative 4 is equal to positive 24. Negative 5 multiplied by positive 7 is equal to negative 35. Positive 12 divided by negative 4 is equal to negative 3. And 8 divided by negative 2 is equal to negative 4. As said previously, repeating decimals are also considered as rational numbers. Here's an example of a repeating decimal. The bar that is over a repeated decimal is called a repeatant bar. Once it's on a digit, that means it repeats until infinity. Next, we have perfect squares. What is a perfect square? An integer that can be expressed as the square of another integer is called a perfect square. In other words, it is defined as the product of some integer with itself. How do we find the perfect square of larger numbers? At first glance, finding perfect squares of larger numbers seem hard, but it is very simple if we break it down into shorter steps. Let's find the square root of the number 441. First, let's take a look at the perfect squares from 1 to 10. The last digit in the number 441 is 1. So looking at the list, we need to find what numbers also have 1 as the last digit. Here we have number 1, which is the square root of 1, and 9, which is the square root of 81. So we have two candidates, and they are 1 and 9. Now that we have our candidates for the second digit, let's look for the first digit. 441 is a 3-digit number, so we're only looking for a 2-digit number. Since the first digit is 4, let's look for a number that is not exceeding or equal to number 4. Here we have the square root of 4, which is number 2. So the first digit is 2. So now let's look back at our candidates 1 or 9. Is 2 less than or greater than 4? So 2 is less than 4, so we have to choose the lower number for the second digit, which is number 1. If you want to check if the answer is right, you can always multiply it to itself. So 21 times 21 is 441, which means that we got the correct answer. Now that we're done with rational numbers, let's move to the irrational numbers. Irrational numbers are real numbers that cannot be represented as a simple fraction. Irrational numbers are neither terminating nor repeating decimals. One pretty notable example is pi. Here are just some of the digits of pi, and you can see how much digits this is. Pi is never ending, which means that it is an irrational number. Another example is the square root of the numbers 2 and 3. Did you know that in 1997, the value of the square root of 2 was calculated to about 137 billion decimal places? In February 2006, the record for the calculation of the square root of 2 was eclipsed with the use of a home computer. Mr. Kondo collected 1 trillion decimal places in 2010.